Hello, I'm Nancy Gomes, Vice President of Business Development for Expedera. Thank you for joining me today for a brief introduction to our company. Expedera is a well-funded Silicon Valley startup developing semiconductor IP for neural network inferencing. Our patented solution offers an industry-leading TOPS per watt with the best efficiency, performance, and latency in the market. This claim is silicon proven by our test chip in 7 nanometer and in the production silicon of our lead customer, a top mobile device maker. The team comes from some of the best-known companies in the industry with a strong background in developing ASICs. Since our founding in July of 2018, we've consistently executed. In our first 2 years, we quickly filed our first patents, developed our leading-edge neural network accelerator, completed a test chip, and won a high-profile lead customer, all before we exited stealth and announced our company. Since announcing our company in April of 2021, we have secured Series A funding, and our lead customer is in production with a high-volume consumer device. That's quite a success story, one which we see continuing. Part of the reason we've been so successful is our leadership. Expedera's team has years of experience developing ASICs and IP. Led by CEO and founder Da Chuang, along with his co-founders Siad Ma and Sharad Choli, Expedera leans on our experience developing ASICs for network switches to provide the best-in-class solution. In addition, the executive team has years of successful startup experience to help Expedera succeed. Let's consider the issues that Expedera is trying to solve. AI inferencing is a multidimensional problem. Throughput, accuracy, latency, and utilization all affect performance. But improving one problem might negatively affect another. Let's look at throughput. By using larger batches, you can increase throughput, but you also increase latency. The extra latency might not be acceptable. Another example, let's say you want to enable higher precision in order to get higher accuracy. Maybe you want to use FP32. That's great, but this can increase your power consumption. Or perhaps you quantize to save power, maybe to int8 or even int4, but sacrifice accuracy. Again, perhaps not acceptable. What is acceptable really varies dramatically from design to design, market to market, and customer to customer. Now let's consider existing AI inference benchmarks. We see the utilization for most SoCs stalling at 20 to 40%. This is true even for well-known benchmarks like ResNet 50. This has led to existing AI solutions being dependent on complex compilers, yet those compilers only yield incremental improvements. To solve the problem, chip architects overdesign SoCs by adding processing power or memory or both, or they might even compromise their design requirements. Inevitably, when applications hit their power or processing budget, they have to reconsider the workloads they can run. All of these problems affect silicon cost, power budgets, and the workloads that finally can run on the hardware, and eventually complicates the deployment in the field. Expedera's Deep Learning Accelerator IP is addressing inference problems head-on and leveraging our networking experience to prevent bottlenecks. Instead of breaking down the problem into low-level instructions, Expedera executes a packet that improves performance and simplifies software. The IP scales from a few TOPS to 128 TOPS with a single monolithic block, again simplifying software and allowing us to deliver a right-sized IP for your application. And Expedera's IP is built on 5 blocks, each of which can be configured individually to support your requirements, from different precisions like int8 or FP32 or even bfloat, to customize activation functions, and functions can be supported post-silicons, future-proofing your design. Best of all, we deliver the IP as RTL, supporting any standard cell or memory library you choose. So why process your neural network in packets? Let's look how it differs from typical solutions. First, the software is simpler. Traditional solutions break the neural network into long sequences of instructions. Expedera sends each layer's metadata directly to the hardware, relieving the software of optimization cycles. Next, the software is simpler. You reduce deployment costs. And Expedera's metadata requires less than a kilobyte per layer compared to over 100 megabytes in some other cases. So Expedera's solution reduces your chip cost, system cost, and your power consumption. And most compelling, it makes deployment in the field faster and better. Expedera joins the leading IP vendors and Tier 1 companies in supporting TVM as our software framework. Apache TVM provides a single interface to deep learning frameworks like PyTorch, TensorFlow, and Onyx, as well as others. It also defines a standardized interface between the DLA and other SoC blocks, and we know that the DLA does not stand in the system by itself. Using the same interface, the entire runtime of the neural network is brought under one umbrella, where we support mixed precision quantization, custom layer support, and multiple job APIs allowing multi-tenant deployment. Customers have visibility from the architectural phase in selecting the right DLA configuration to the deployment phase, where the right power, latency, and inference per second decisions can be made according to the system goals. Expedera's DLA and TVM provide a future-proof solution as neural network models evolve. Everything comes together with the best performance, power, and area. It comes back to PPA. Expedera delivers 5 to 10x performance improvement over competing solutions. With reduced bandwidth, DRAM is optional. Expedera's DLA IP is scalable, that you can use the same IP architecture for products today and tomorrow, and your system cost is lower. And all of this is protected by patents that protect you. Now that we've talked about the requirements for a DLA and the advantages of Expedera's technology, it's time to introduce our product family. Expedera today offers 3 families of products, each targeting the specific needs of your SoC. The Origin E2 family is intended for products that can't afford the power and cost of adding DRAM. Origin E2 runs neural networks on chip and is appropriate for mobile and battery-powered applications. But while it's geared towards mobile applications, it is a powerful engine capable of processing a 4K image or video at high IPS. The Origin E6 family is intended for the more general-purpose DLA applications and can run 2 jobs at a time. This is the perfect option for SoCs that need DRAM and require high performance. And lastly, the Origin E8 family is our top-of-the-line engine targeting high-performance applications. Offering 32 to 128 TOPS in a single core, Origin E8 serves applications with multiple jobs and high data streams, such as data centers and automotive applications. As I mentioned earlier, Expedera's IP is silicon-proven at a number of leading nodes. For the following comparisons, we will be discussing 7 nanometer. The Lindley Group reviewed our product and determined we produce 5 to 10x better TOPS per watt than other DLA IP solutions. And Expedera's Origin IP achieves much higher throughput and utilization than the industry averages. When you add our TOPS per silicon area metric, we outshine all the alternatives. As always, the PPA metrics, power, performance, and area, are key to a successful SoC deployment. I don't want to be too repetitive, but again, PPA is king when considering a silicon IP. Here again, Lindley compares Expedera to leading solutions. We achieve the highest performance per power efficiency, hands down. That wraps up my introduction to Expedera's Deep Learning Accelerator. I want to leave you with a few key points. Expedera leads the industry with 18 TOPS per watt. We provide predictable inferences per second. Expedera's packet technology improves performance and simplifies the compiler software, reducing support burdens for you and your customers. We scale to meet the needs of your products from 1 to 128 TOPS or more. The Origin IP is easily configurable to meet your specific needs. And when you finally get silicon, our best-in-class performance simplifies deployment with the Expedera Origin product. I hope you found the introduction to Expedera helpful, and I look forward to helping you with your next SoC. Please reach out to us at info@expedera.com. Look forward to talking with you soon. Goodbye.